Okay, so I'm going to show the latest release of Alge, a feature that improves its usability a lot. I was pretty excited about it, and it's much easier to show than write about. So I'll do that. And most of the shout out goes to this tool. I mean, all the shout out really goes out to this tool, ts-toolbelt by Pierre. He's actually a colleague of mine at Prisma, a great guy, and really appreciated his input today on just something at work. And he pointed out that my issue with Alge could be solved by this type called compute, which I will show as well in a bit how that worked. But first, the effect of it and what the problem was. So I have two versions of Alge in front of me. I have one on the left, I have one on the right. On the right is the old one, and the improved version of Alge is on the left over here. So the problem was that in Alge, it's heavily based on inferred types. Great, because you don't have to write type annotations, but bad when the inferred types lead to gobbledygook. You, of course, still get the benefit of the type safety and the autocomplete, but you really have to kind of go deeper for that. So like when you look at what does the controller returned here look like for your data, your algebraic data type shape, this is pretty useless, I would say, for like even me as the author, like I find this pretty useless. And so I'm pretty sure everyone else in the world is going to find this useless at that point. I can, of course, then in practice, right, I can go down and start working with the shape, and this is more useful, like this is great. But even then, right, some things are simple, like let's say name, right, is just a string literal, and there's nothing there to kind of tease apart. There it is. It's simple. But there's nested structures that continue to exhibit this problem. Like the circle namespace for that member of the algebraic data type is the same gobbledygook basically. And see if I can. I'm a bit of a small space here, so the autocomplete's not ideal. If I can close that up a bit. There we go. That helps a bit. And rectangle, square, the same. The from is kind of more readable. You can see that there's this JSON, got this union return, but the intersection is always somewhat not great. You kind of know that those fields are going to merge, but why don't we just see them merged, right? And anyway, and so that's some of the issues. Take a look at then like the constructor for this is maybe even worse, because this is the kind of thing that should just like you're often going to just maybe be interested in what the input is, and then you go to look at this and you say, oh, I have like this just no clue what the hell the input's supposed to be. Maybe there's like a radius, okay, with a Zot number. Wait, oh, is there a Kodak? You're like trying to, and the reality is there's only a radius, right? But that is absolutely not obvious enough looking at this type. This is horrific. So that was crappy. I hadn't really thought about if there was a way to solve that, and Pierre today pointed out that there is. And it was actually in the context of something else, to compute the type of thing, to compute a type, to force TypeScript to kind of compute a type. And I realized that this other conversation we're having, the solution could apply here. So this is on the left, like I said, on the left side, the improved version, and it's the same code. It's the same example. It's geometry, data, complex. So I'll close up these sidebars there. And let's look at the same things we were just looking at, but this time for the good one. Look, so you can see you don't have these sort of generics composing and with type parameters being passed in. You just get sort of the computed result. Rectangle is a namespace. It's got these properties. It has a method update that has, takes this input, and it's just kind of beautiful. And I mean, might be what you expected. So this might just be like, okay, now it's normal as opposed to crappy. But as the author of this, I was like kind of just, a little bit had sort of given up or submitted to this problem and just resigned myself. So I was pretty excited that this is possible and just works. There's a little thing on the encoder the graphic encoder here. For whatever reason, there's something that about it that didn't quite kick in for the compute. And that's the one glitch, something probably in the implementation that's leading to that result. Somehow it's different than, for example, the, well, for one thing, the decoders, right? The graphic decoders, they work fine. Anyway, there's a tiny little, but already this is a huge improvement. So I'm fine with some imperfection. Look at the create, like, wow, that's just great. Is what exactly, like, it is exactly as simple as it ought to be. Probably the only improvement here that I could potentially see would have been, it would be nice if input could be given so like this input takes a radius number. It's sort of the guts out, right, of your algebraic data type member. But it might be actually nice to see this as sort of more of how you would see it if you had defined an interface, which this would just be a circle, right? So you just see circle in at the same time being able to peek, and then what are the properties of circle is would have been a nice touch. So sort of being able to alternate between the kind of named version of that member plus its properties is definitely advantageous. I'm not sure if that's actually possible even with an interface in the kind of IDE experience here, but anyway, I guess guts out properties is still, it's not that bad. Yeah, like this is very usable. Again, going back to what it was before, this is just awful. It's just awful. It's not bad enough to make me not see the benefits of Alge, but like it was kind of a pretty sad trade-off. This is great. This is like you can have your cake and eat it too. So there's other areas across the Alge code base that kind of benefit from this. Let's see if we can quickly explore that. So like as I navigate through here, you can see the from here is whoops. The from is everything is looking good there. Whereas if I go back there, whoops, with the from is also actually wasn't so bad in that case, right? Again, but it does have those ampersand. And see the was a fine. The update's pretty awful here as well. So if I stretch this out, okay, well you can see it's got this partial, right? It's got the dot dot dot. Yeah, I can. Sorry, I can. Let's see, update. Okay. So here you've got partial, omit tag, circle, blah, blah, blah. So you have to kind of be like, okay, like eyeballing this, do changes accept the tag? Oh no, it says omit tag. Okay, well probably omit tag means that this tag thing will be gone, but you kind of have to know the implementation detail it's reasonable, but like it's and then it's partial, which, okay, that means radius can be optional. That like, you just the time to parse that, again, for me, I hate that kind of thing. So if we look at the new update, boom, tag, don't think about it. Radius, yes, it's optional. It's just in there. Don't have to kind of engineer that computation in your head. It's done for you. And yeah, again, update looks great. So maybe there's a few other big wins in the API there, but that gives you a sense of the big difference there. And again, huge shout out to Pierre's library for making that magic happen. Maybe a quick like look at where that happens in the code base. So it's under a namespace called Any. So Pierre's library, ts-toolbelt, it has a whole bunch of helpers. It's pretty like extensive set here of namespaces for different categories of tooling, of type tooling. Any is not, I don't think any is a reference to like the any type. It's more just utilities that could kind of work with any kind of type in TypeScript. So I'm particularly interested for these changes of just one utility type, which is the compute. And you can see here some nice JS doc. And as it says, force ts to load a type that has not been computed. to resolve composed types that TS hasn't fully resolved for display purposes mostly. So it's even says, I guess, that this kind of use case about being able to better display types for humans. That seems to be the main use case apparently for this kind of thing. There's an option for flat or deep. Deep is default. Flat means that it won't recurse into each of the child properties of properties of properties of properties. Computing all those. That can be useful. The reason I did that, for example, is I didn't want to, in the API, you have the schema, which is this like Zod, structure. And I don't know if there's a performance penalty to do so. So right now I just didn't want to kind of compute everything that's in Zod. I wanted to skip that. So I do a flat compute here. And then I do kind of more granular computes on some of the other parts of the Alge API. And yeah, so that's it. I think it was a really cool kind of win on the TypeScript design of the type side things in this library. And definitely something I'll be using probably in most of my library work in TypeScript going forward. So thanks for listening. Ciao.